Okay.
Working on all the bugs. Welcome, and I'm so glad you came to join us here at Airborne. I would like to introduce my my virology team, Michelle Thornton and Sarah Lumpkin, and I pulled this session together because we really felt that the Airborne workshop at NASA in March provided a lot of good feedback from data users and data producers, and we wanted to share that with you and make sure that you all had feedback and the findings that we're discovering from that feedback, analyzing that. So there is a document that's in the folder for this session. And if you go in there, if you add your name showing you were attending, and then you'll see below there's some resources. One of them is an article that was posted in data back in May. And then there's a link to the Earth Observer, which will have a more extensive article coming out in this session that should be released any day now. So late July to early August will be the next edition. You'll see that we've got an article in there as well. Also, there is a link to the workshop website, which has the full recordings of the 2-day workshop. And if you want to know more on that, go ahead and spend a little time. It's quite a bit of material. What we're going to do now is first introduce ourselves and what organizations we come from and why we work on this. And then we'll dig into, we've got some speakers to hear from, one representing a DAC, a data producer, and a data user. So we get all perspectives. And then we're going to go ahead and have some activities that will get us all up out of our chairs and wake us up this morning. So without ado, am I first? I am.
You're first.
All right. My name is Deborah Smith, and I work for the Airborne Data Management Group.
One online audience says it has added. You want to try using the microphone?
Yes, I will. Sorry, I forgot I'm speaking way over there. I'm with the Airborne Data Management Group. This group was formed in 2018 based on a Satellite Needs Working Group feedback survey that said that the airborne data needed some love, and so we've been giving it that in NASA. It has been the kind of stepsister to the satellite data in NASA, and so it's needed quite a bit of work. The primary tasks for us is to take a full assessment of what airborne and field activities have occurred in NASA in the past 5 decades, to develop a metadata-rich inventory that everyone can access from one location, like a knowledge center of airborne and field, to develop approaches for best practices so that we improve how we're handling airborne and field data in the future, and to maintain a knowledge center and the improving of the communication, which is why I work with the DACs and ESDIS in order to help make change. Sarah?
Hi, so I'm Sarah. I work for the ESDIS project, which manages the system of it's EOSDIS, the Earth Observing System Data Information System. And that's a comprehensive system that's made out of the SIPs and the DACs that manages and supports NASA's Earth Science mission data. So we're responsible for the ingest, archive, distribution, and visualization of all types of Earth science data, including naturally satellite, that's what everybody thinks of first, but field campaign measurements, airborne data, in situ data, model data, and all the ancillary products that are used for processing and other related data sets. Yeah, and so that's what the ESDIS project does.
Hi, good morning. I'm Michelle Thornton. I work at the Oak Ridge National Laboratory DAC, and I'll tell you more about the DAC or what DACs are in a little while. But I've been at the DAC since '09, and as many of you know, the DACs are kind of in the trenches doing the day-to-day standardization, curation, archive, documentation of data sets, including airborne data. And at the DAC, I'm the airborne data lead, so I collaborate a lot with Deborah and Sarah. Thanks for being here.
So I'll just cover quickly the agenda that we're going to have today. I think I just mentioned it, but we'll go over it. We're going to recap the Airborne and Field Data Workshop, what occurred, and some of the findings from that. We have the 3 presenters, and then we'll have 2 activities and a recap at the end of the session, and we hope you find this really valuable. Sarah?
Okay, so way back in March, at the end of March, we held the first NASA Airborne and Field Data Workshop. And we did this because Deborah and Michelle and I are part of a bigger Airborne and Field Data Working Group, which is made up of the DACs that handle problems. No. Oh. How about now? But it looks not in presentation.
How about online?
Yes.
Okay.
Okay, so let me go back. Okay, so we have this Airborne and Field Data Working Group that meets monthly to talk about what we can do to better serve the airborne community. And we decided that we needed more information in order to really do a good job. So we held this Airborne and Field Data Working Group, and our goals were first to identify new ways to improve discovery, access, and reuse of NASA's airborne and field data. We wanted to intentionally include the airborne community in this workshop to help with future planning, to make sure their needs are met. We wanted to understand how we can better help researchers realize the full value of this data. And we wanted to do this in an open way, enabling open source science, which, as you've probably heard, is a big priority for NASA right now. And we wanted to determine what this means for the airborne and field data communities. So we had 272 people registered for the workshop. They did not all attend at the same time because it was virtual. People dropped in and out. But at any time, there was like 50 to over 100 people there. Most people, because attended on day 1. We had the lowest attendance, of course, at the end of day 2 as we were wrapping up. I guess that's the way it goes. Yeah, so here you can see it was pretty, I mean, we had more data users than data producers, but there were a lot of people who identified as both data users and data producers. And then those who were neither were people from the DACs, from ESDIS, from NASA headquarters, who help manage this data and were interested in the outcomes of the workshop. Most of our attendees were mid-career, but we had a good representation of early career, late career students. So we had a good, diverse attendance. Yeah, we also were interested in what communities were attending. Atmospheric science, of course, was a lot of atmospheric science people there. But yeah, several disciplines showed up. Lots of applied science people. Okay, and then when people registered, they were asked, what feedback do you have to give us about NASA Airborne access, data discovery, and or use? And it seems like people's priority was easier data discovery and access. So that was just like an initial feedback going into the workshop. So like, I don't think I said this, but our first day we focused really on what the airborne data user community needs. So we had airborne data user community members come share their experience. We had invited talks from some NASA-funded PIs who are using NASA data in their work. We had a moderated user panel, and then we had breakout groups where data users could discuss their experience. And then we had representatives from the DACs and ADMG talk about what tools and resources we have available for users of airborne data. Day 2 focused on the data producers. What do they need? So again, we started with talks from the data producer community. We had 6 PIs, or I think data managers from different campaigns give the flash talks. And then we had some conversations about how we can work together to help make their data available faster and make it more accessible and make it easier for them, for the user community to use. And we intentionally put the data producers after the data users so that the data producers could hear what the data users needed. And then we closed out by talking about looking to the future. So we have 3 speakers from the different communities that we had at our workshop today. Our first is Gao Chen, and Gao is a highly experienced campaign data manager who works at NASA's Langley Research Center, providing field data archives that address the needs of campaign data producers. Gao is involved with many airborne campaigns, and he's going to share his thoughts on airborne atmospheric chemistry and composition data issues. Michelle has already introduced herself, but she is the airborne data lead at ORNL DAC. She's been at ORNL DAC since 2009. She's on the ingest team, archiving and curating data there. And she is also a member of the ESIP Standards Coordination Office, where she contributes her expertise in handling airborne data. And then our last speaker is going to be Yoselin Angel. She's a postdoc at Goddard Space Flight Center, and she works on retrieving plant traits, ecological modeling, and hyperspectral remote sensing of vegetation. She has a background in remote sensing and environmental science with more than 10 years of experience collecting and using field, UAV, airborne, and satellite data. So we are going to start with Gao, and we need to share Gao's slides. Yeah, so they're already open. And is this what's showing up? Where is it here, the PowerPoint? It's here.
Okay.
These are Gao's.
Okay.
So we just need, so.
It's the 7 one, right? Talking about this. There's one called this one, right?
This one, yes.
Yeah.
Not showing up yet.
Not showing up.
Is it right now?
Still Sarah's.
So you might need to share these.
Yeah.
All right.
Okay, perfect.
So Gao, if you just let us know when to advance the slides. Gao,
Oh, muted.
are you muted?
Hello, can you hear me now?
We
Sorry.
can hear you. Great.
Okay, so Sarah already talked about what I do, so that's pretty much showing the first slide. We're in the middle between the science team and the DAX, and also, I mean, you can read the slide, and so I don't have to talk through it. So next one, please. Next slide, please. So I'm an old guy, so I've been to many field campaigns, and I was doing the real data in terms. I mean, I started with measurements and did modeling, and then since 2008, I started doing data management. And Rama, I think, in the room, helped me a lot to get started. And recently, I joined the WMO expert teams trying to work on the data, metadata standards apply for the in situ measurements. So this is briefly what I do. I mean, between things, I probably did some like a data product and a tool development, but that's minor stuff. Okay, next one, please. So this slide pretty much trying to tell you what we do as a data repository, right? So we support the NASA airborne field campaigns. Yes, mostly we support atmospheric composition field campaigns. However, from here there, we also support other campaigns too. Like right now, we're supporting CPACs, which is not a traditional composition focus area campaigns. We also did similar things before. The upper atmosphere program or focus area. So in addition, we support ground network like TONET. This is a tropospheric ozone LiDAR network, and also INDEC. That's an international network, which is important to the upper atmospheric research program. So basically, what we do is we try to make sure the data can come in, data can go out to the science team. And we do try to scan the data, make sure that the data product is usable or readable. And in addition, we do some data product stuff. And since ADMG, we probably got, we have better clear directions. So we follow their directives and also give them feedbacks. And one thing is that recently, there's different activities going on within NASA. So they request us to produce specific data products. So we use our expertise to do that. And because we deal with the science team a lot, we see a lot of problems with the metadata standards and also data format problems. So we try to do this from the grassroots level, trying to develop some community standards and move forward from there. Okay, next one, please. So this is one example. You guys probably know the AOS. This slide is from Arlindo da Silva of GMAO, and he specifically requested us to provide data in a specific format, like a NASDAQ format with the MACI requirements for this project. So we're doing that. We're in process of doing that, and also we're converting some other direct observational data to this kind of to comply with these requirements. So next one, please. All right, next one, please. So what's the fundamental challenges? I want to talk about this a little bit. So everybody talk about open source science and open data. We want something actionable. So what is actionable to the field campaign community? We can do the accessible part because that's a DAC's job. But what we can do is we can make it more findable and interoperable and also reusable. By the way, I do have a problem with the word reusable, so that's why I put it. Anyways, but that's fine. So fundamentally, typically we need to start a domain relevant metadata. These metadata are not just spatial, temporal, and something generic. This is specific to the instrument. We're finding out more and more this is needed. And after that, we need to implement these metadata standards into the format standards so people can properly report these metadata. Next one, please. So this is another grassroots effort. This is an interagency group chaired by Jeff Reed of NRL Naval Research Laboratory and also Jeff Stair from DOE. But this slide is from Jeff Reed. So basically, it's showing why this is important to us, and many things are actually. So I would say the metadata schema-wise, I think WMO WIGOS has the best metadata schema. However, in terms of standards, there's a lot of gaps, and let me just put it that way. Anyway, so we're working on it. We're leveraging all the efforts from Europe, from US, and try to make the best of it. Next one, please. So this is the guidelines in addition to CF, and we're trying to make the files as CF compatible as possible. And so this is something we're trying to test, implement in the recent field campaigns like CPACs, like STACs, and a TracerAQ and a MOOS. We have we're still testing water. So we adopt a lot of CF stuff. However, we do have a specific attributes needed or the requirements needed for the data we're dealing with. And one thing I want to point out, the unit is always a problem because for the same kind of a variable, people are creative, and that makes things less interoperable. All right, next one, please. From moving forward, we will work with ADMG and other people. First, we need to try to figure out so because we're dealing with field campaigns directly, we want to figure out something very specific for each instrument. So something important for HSRL may not be relevant to APR3, right? So this one is radar, another one is LiDAR. So this kind of stuff, we need to at least collect use cases and then work with ADMG and a standard office trying to figure out something to standardize these things. Uncertainty reporting is a fundamental problem. I had a problem with the data quality working group, and now I'm working with the WMO measurement quality working group, and finding out actually the root cause is the BIPM definition and the vocabulary has issues to deal with the atmospheric measurements. We're working on that, trying to figure out what to do, and if we can, let's try to apply the standardized units to everybody. And yeah, I just talked about the SDF and CF requirements, additional requirements in addition to the CF conventions. And then ICAR, maybe it's time to do another refresh. All right, I'm done. Hopefully I didn't drag too long.
Thanks, Gal. Michelle, you're up next. We need to stop sharing this one. Do we need to?
Yeah, so we'll bring up my slides here.
Your slides are middle ones. And then we need to. Yeah. Share the screen. And then it's this one. No, screen. Oh, screen. There we go. Share. Good. Editing presentation. Thank you. Great. All right. Noticed in meetings that sometimes people's heads are cut off. Okay, thank you. So I'm Michelle Thornton. Again, I work at the ORNL DAC. And being at ESIP, I realized that not everybody is a NASA person and perhaps doesn't understand the nomenclature and all the acronyms. So just a little bit of time about what a DAC is. So DAC stands for Distributed Active Archive Centers. NASA DACs process, archive, document, and distribute data from NASA's past and current Earth-observing satellites, airborne, and field measurement programs. And each DAC that you see here on the slide is domain-specific relative to the data that they archive. And so the ORNL DAC focuses on terrestrial ecosystem and biogeochemical processing data, process data. And then the rest of my presentation, I'll focus on the ORNL DAC. That's the DAC that I know, but there are many DACs that do archive airborne data. And part of this collaboration and the work with ADMG and ESDIS is to foster that communication across DACs. So the Oak Ridge National Lab is, we focus on terrestrial biogeochemistry and ecological dynamic observation. So we have a lot of data, not just airborne, but airborne data related to those topics do come to the ORNL DAC. So as the airborne data lead, I do participate in monthly airborne meetings that Deborah and Sarah mentioned, so coordinating with ESDIS, ADMG, and other DACs.
And from that meeting, I'm able to convey any standards or best practices in curation and archive to my team, not my team, to my colleagues who work with QA, documentation, curation of those data sets. So making sure that standardized formats, metadata, consistent variable naming, like Gao mentioned, trying to get some of those airborne standard naming conventions throughout the DACs, consistent definitions that ADMG is providing the groups, and then GCMD keywords. So really working with Earth data and the community to have a consistent picture of airborne data. And then I also participate in activities supporting the airborne and field data community, including the Airborne and Field Workshop, and coordinate with colleagues and participate early and often in science teams and science team meetings. So really trying to start as a NASA campaign gets off the ground and starts flying, knowing what those data are and communicating with the science team. Also with my colleagues engaging with Earth data cloud migration activities. There's a lot of talk about that right now. So staying on top of what are the optimized file formats for cloud data for legacy data sets that we have, and as we move forward, what are the access methods that are being developed by Earth data, and how can we contribute data and activities to that? Paying attention to the web services and tools that are being developed, and trying to, for example, the slide has just a flight path of AVRIS NG data. So the ORNL DAC is archiving those data. I'll talk about that later. But those come to us from JPL in an NV proprietary format. So how do we transform those data into something more cloud optimized that allows subsetting both spatially and temporally? So NetCDF, STARC, or Chunk, cloud optimized GeoTIFFs, all those formats are being looked at, and with the broader NASA community, we're looking at that so that we can make the right decision when we look at transforming those data. Another thing that I do is look for opportunities to collaborate with the science team, with science teams that are doing airborne campaigns. So an example here is Delta X. Is a large NASA project right now that has a number of airborne instruments that they're flying. The Delta X science team did an applications workshop back in May and spent 2 days. It was a really awesome workshop, lots of material, lots of lessons, lots of Jupyter notebooks, accessing data that we have at the DAC, and really walking people through how to use those data. And so we reached out to the Delta X science team and asked if we could include all of those resources in our learning resources material. And that way we can connect those Jupyter notebooks, those lessons to the data. The science team doesn't need to worry about sort of making those connections. That's a good thing for the DACs to do. And then this summer in August, myself and a couple of colleagues will go to ESA, which in my mind is the Ecological Society of America in Montreal. And part of what we'll do is we'll share with the community those resources that the Delta X science team provided to us. And so we can broaden that knowledge base. This is kind of a busy slide, but what it is just a note that says these are the active airborne campaigns that the ORNL DAC is currently working on. So there's quite a few campaigns. Some of them are specific airborne instruments that we're working on. Some of them are broader campaigns like the Above campaign or the Delta X. And if you're in the NASA community, you know what that means. If not, they're really cool campaigns. And a lot of them have not just airborne with it, but also field data, a lot of modeling work going on. And so there's a lot of data that we're archiving, not just airborne data with those particular projects. But the column on the right shows what, in my mind, we can kind of group the airborne work that we do into sort of 3 broad categories, and one is what Gao was talking about and is very involved with and has expertise in, is the atmospheric composition and chemistry. So those data, and then there's passive and active remote sensing that particular instruments are doing. So I think of it that way, and those products are, the data products themselves are sort of grouped into those categories. I do want to mention the two campaigns that we recently curated, Act America and ATOM. Those were really critical to understanding and improving our knowledge of the atmospheric chemistry and composition. So those were a couple that we just finished up. So a new twist on things is that ATMG is leading assigning DACs to a facility instrument. And a facility instrument, the definition is on the slide. They operate out of a NASA research center and support multiple science disciplines, field investigations, and NASA science objectives. So the ORNL DAC has two of those. One is called MASTER, which is a Modus Aster airborne simulator. The other is Avris Classic and Avris NG. And both of those are image spectrometers, spectrometers that are flown on airborne platforms. And we are archiving the radiance and the reflectance data for each of those instruments. So they're similar, but they're different. And it introduces unique opportunities to think about how do we archive those data, how do we make them accessible and discoverable, not as just a facility instrument, but each of those have flown for specific campaigns. Avris especially is getting a lot of use this summer. And so we want to make those data discoverable. And one way we're doing that is thinking about something as broad as GCMD keywords. So having master as an instrument keyword, but also including the project that campaign was involved with. And then some of the challenges of accessing the data. So this is a subset of flight paths over California. The top one is master, the bottom is Avris. So lots of unique challenges and opportunities for accessing data that are coincident. Gao mentioned, I'll just highlight one of the things that we do at the DAC is we do work on converting an ICART, which is an ASCII CSV file format that a lot of airborne data, especially the atmospheric chemistry community uses. So converting that to NetCDF, and that allows us to tie in those in situ measurements to the flight path. And we can then display those and improve their access. We have a number of other airborne tools, and I'll just run through a couple of those for the sake of time. So one of them is the Airborne Data Visualizer, and this is a really great tool. I think it's a great educational tool if anybody is in education. But it's a Python-based web application, and it allows the display of flight paths. So you can see that you can plot out two different variables or a variable by elevation through a flight path and visualize so how CO2 measurements, for example, change over elevation. And then the spatial data access tool is based on OGC standards, and the example I'm showing here is from AirSWAT, so it's a level 2 gridded data product. So this tool is specific to GeoTIFF files, and it allows a user to come in and subset spatially or temporally and reproject the data to their specific need. And that's all I have. Thank you.
Jocelyn, are you able to share your screen now?
Yeah, sure. Can you see the screen? Yeah.
Yep, and you sound great. So I am going to mute the room here. So yeah, feel free to start whenever you're ready.
Okay. Well, thanks, Sarah. And thanks for inviting me to participate in this panel. My name is Jocelyn Angel, and I'm a postdoc in NASA Goddard Space Flight Center at the University of Maryland. I'm a user of airborne and field data, specifically within the field of hyperspectral aerial images and field spectroscopy. For the retrieval of plant traits, for modeling these plant traits as well, and also ecological modeling. And I'm also working in the monitoring of phenological dynamics using this data. So it's very specific, like within the airborne community users. I'm dedicated to use the hyperspectral or the spectroscopic data. So for this presentation, we have like 5 to 6 different questions, where I will try to answer, providing my feedback and my experience. So the reason I use this data, the reason I use airborne and field data is because I'm looking for high resolution and very detailed in situ observations. So when I say high resolution, I mean high frequency time series with hundreds of spectral bands and a good or a high spatial resolution, like centimeters or meters spatial resolution in the images. Currently, I'm using some products from NASA, Aviris NG, G-Light, also making some synergies with other programs like NEON program. They collect also hyperspectral imagery, and they provide also plant traits in situ measurements from connected with plant traits. Here you can see an example of one of these sites that I'm focusing now. My attention is in the Smithsonian Research Center in Maryland, where the NEON program has been collecting a time series during the last 4 to 5 years. They provide the aerial images, they provide the plant traits, and you can access everything together with protocols. You can access these also with methodologies and the different instructions of how to use and how to access this data properly. Also, I have some experience. Most of my experience has been collecting and leading field campaigns using UAV-based hyperspectral, but I'm going to focus on the NASA products in these slides. So, well, basically, for accessing these data, I follow 3 general steps. Very simple: searching, querying, and downloading. It will depend on the location. It will depend on the specific requirements, like if I'm aiming a specific ecosystem or aiming a specific season or a specific location, as I mentioned before. So generally, I access these portals that you can see here, the Aviris portals or the G-Light portals. There's another portal that is supported by NASA in collaboration with some universities, the Ecological Spectral Information System, ECOSYS. And sometimes I also search for this data in the Earth data repository. Here, what is challenging in this workflow, in this simple workflow, is downloading the data, because this is big data and we have multiple repositories, and sometimes I have found that there are different versions of the same data within these repositories. So considering that we have here like pixels with highest spatial resolution, with hundreds of spectral bands and time series of images, I have to keep in mind that I will need terabytes of space to save this data, to process this data, and also to compare the different versions that sometimes I found within these portals, to then start with the modeling and retrieving some plant traits or mapping these plant traits and some assessment metrics. Some other challenges and opportunities related to using these data. So in terms of this discoverability, I can say that if I'm looking for data specifically located within the US territory, I will go for the NASA repositories. But if I'm looking, or if I aim to look for data with out of the US territory, I will have to Google and look for data that maybe some other spatial agencies or some other research institutes are collecting or have been collecting. And within this, it comes the challenge is looking or accessing different or multiple portals. Specifically, going back to NASA portals or NASA products, the availability, most of the images or most of the projects have make the data available and accessible. So as you saw before in the previous presentation, there are different projects with a specific purpose. So some of these projects maybe are private or require a specific access, like you have to send and submit request permission for accessing this data, but most of the data is available in the portals. Regards to the data formats, I can say that I'm fine with using all the different multiple formats that you can find these images and also the field data. However, because of as part of my research doing the modeling in trying to model time series, I prefer to go for automatizing or to make automatic processes. So when trying to automatize these processes, I will have to go through a pre-processing step of putting everything in the same format, and well, it is also challenging. In terms of standardization, I can say that most of the images, most of the field data just follow the OGC or the international standards. This is fine. However, in terms of field data or in situ observations, perhaps there is an opportunity here to provide more use more information like metadata, but not only metadata, but also protocols, more details about the collection, how this in situ data was collected, how this data was processed. All this information is useful for using for a user when you want to use in a good way these in situ observations. Well, I want to share with you something that is I'm just starting to use and is working until now, and it's using cloud computing. So at the beginning of this year, as part of as part of the mission of the SBG mission, we ran a field campaign in California with the Avidis sensor, collecting a high frequency time series of images. So it's very big data. I'm starting to use cloud computing environment. This project is cloud computing environment is managed and led by Alexei Chiklomanov, maybe you know him. So here we're trying to use Jupyter on Amazon server, doing the same, trying to reproduce the same that we usually do in our local computers or in our cluster computers, trying to reproduce this in the cloud. And until now, it's been working very well. And as I told you, because of the data, the size of the data, well, it's saving a lot of time, and also opens the opportunity to share with other people, with the rest of the community or the rest of the team, your code, or actually interacting in the working together in the development of the code or the analysis. And finally, some of the challenges of this air data search portal, the discoverability of these hyperspectral airborne data within these portals. So I will mention first the versioning of the data with other NASA portals. So here you can see an example of the same data when you look for Aviris data in the Earth data portal, and when you go to the Aviris portal. So I usually go first for the Aviris portal because it's where I can find the complete list of projects or the complete list of imagery, multitemporal imagery there. So occasionally I will go for searching in the air data search portal. But yeah, I think this is an opportunity to try to make them consistent, so you can find the same data in both, or to combine them. I'm not sure what would be the best, or just as I said, just to have the same versions in both portals. Also, as a user, this is more like an opinion as an user. We are still surfing in this portal. Like, it makes it it's like the experience on the experience that you have in Google. Like, you can, there are amazing tools like the search. If you search for a specific word, like a keyword like airborne hyperspectral, you will find the projects, and you will find different access to different projects related to airborne hyperspectral airborne campaigns. The archive is graded, but the experience is more like still surfing on the web. I think, and this is just a suggestion, or maybe it's just an idea that I've been thinking in terms of the way today most of the interface user experience work is thinking something like in the way how Netflix, for instance, the Netflix recommendation engine works. So when you have the profile of your users and you have the specific preferences of your users, you can have a better idea of how to provide updates, or how to provide news to specific users, to make the search and to make the notifications to these users more useful or more easy, let's say. Well, that's all what I have to share with you. Thank you.
And we'll share the screen again.
Thank you, Jocelyn. I don't know if you heard us speaking.
No, I didn't.
All right. Well, you got applause, and we thank you for your opinion.
Thanks.
Great. All right. And we have to share screen.
Not sharing screen again? No, not yet. Okay. Difficulty.
Check another.
So here we go.
There we go. Let's get to the right spot here. So thank you to all our speakers for adding their perspectives about airborne. And as you can see, we found similar perspectives in our workshop. And what I'd like to do now is do a quick summary of what's happened since that workshop. There is a team of about 7 to 10 of us that we meet weekly to kind of filter through all the feedback we got. We had way more than 150 individual pieces of feedback that we wanted to consider out of all of the ways in which we collected feedback from the attendees. One of the ways was simply a Jamboard, looking at kind of what's their concerns about tool use or data access. And as you can see, we get anything from Earth data search issues, as Jocelyn mentioned, to I would have liked to see more presentations by data provider types, comments about the workshop itself, as well as the need for API access or constant variable names or in flight track information provided so that one can see where the flights were. This type of information needed to be filtered through. We got it from a Jamboard, we got it from surveys, we got feedback from questions and answers and comments in the chat. All of this needed to be filtered. We started going through all of the different comments and then categorizing them into logical categories that make it easy for us to kind of say, well, this is all about cloud, this is all about tools. And that way we could dig in more into each of these categories. In doing so, in the months since the workshop, we found that there was a set of major themes that were evolving. And these are the themes, and I'll go into each of them, but the importance of communication among all stakeholders. I think for several decades we've had not the best communication between the science teams and the data providers who are creating, the data producers who are making the data and handing it over to the DAC and the DACs themselves. There seemed to be a bit of a wall there, and we're really trying brick by brick to remove any kind of wall between these two entities. And as Michelle mentioned, having the DAC get assigned to the team earlier and become a team member during the campaign has gone a long way towards improving relations. Also, the need for cross-DAC consistency in data handling, because as you've heard, the DACs are arranged by theme, scientific theme. So you get bioterrestrial in one DAC, and you get weather and severe storms in another DAC, and oceans in another DAC. And so if there's a campaign that crosses any of these areas of study, then the data gets spread around in various DACs, and each DAC has its way of handling the data and publishing the data. And then you split up instruments, which is why we came up with the facility instrument idea, to get it all back together in one place when you've got an instrument that's highly valuable and crosses many campaigns. There's also another theme of improved data discovery, access, and use, especially on the discovery side. Atmospheric scientists especially were concerned about how difficult it was to find the data that was at many DACs, and the issues with using Earth data search. Also, the provision of additional information and resources. And I think this is important to recognize that satellite data occurs is obtained from an instrument that's in orbit. What's the scenario there? It's really kind of easy to explain. It goes up at one point, comes down eventually. Turn on the instrument date, turn off the instrument date. That's the context of that operation is fairly easy to understand. You know the orbit, whether it's a polar orbit or a geo orbit. There's not much there to have to know. But with campaigns, you have specific objectives, specific regions, Earth surface types, lots of different details that matter in understanding this heterogeneous collection of data. And understanding all that context is very important to making it really useful in the future when the science team has moved on and this data is still there and has potential uses that we don't even necessarily understand yet, but we don't have the information behind it, the context. So the importance of communications, we felt that these 3 bullets represented a lot of the different kinds of comments, that we needed to have more subscriptions and easy to use instructions so that users would be notified when new data came along. This happens a lot. A campaign will be completed or near completion, and there'll be some data published, but then in 6 months or a year, the scientists will create a new data set. And then it'll get published again at the DAC, but there's no system for notifying scientists who have made use of that data, and we need to make sure that that happens. Improve communication between DACs and data producers. We can drill that one in all the time. Provide data producers with more help, and this is why we brought the DACs in early on. The need for cross-DAC consistency in handling data. This can extend anything from units to file formats to variable names. Clarification on data producers, for data producers on standards for cloud-optimized data formats. I think it's one thing to say we're making open science and let's figure out how to do this, but what does it mean for satellite? But what does it mean for airborne and field? And that's where we are right now, is starting to take a look at that. Provide data format templates to help data producers create better data sets. And the data producers development guide that NASA has provides general information about how to make better data products, but all the examples in that document are for satellite. So one of the things that ADMG is doing right now is working with the data producer development guide folks to insert more airborne examples. And the third area is improved data discovery. We would provide an overview page with all available airborne missions. That type of thing is done with Casey. I don't know if any of you saw my poster yesterday. That's what the Airborne Data Management Group has been doing, is building a one-stop information area for all NASA airborne and field activity. And so that's being met by that need. Provide ways to search for targeted compounds. This is very important, especially in the atmospheric chemistry and composition area, where there's lots of different compounds and they want to be able to search by any one of those. It's very difficult to do so right now. And then particularly for atmospheric composition data, provide a means to search based on altitude in the because they do a lot of up and down through the atmosphere. So searching by altitude is not available right now, and that's something that they would like. Provision of additional information, enabling the community preparation of Jupyter notebooks. A lot of scientists do their own coding, and then that code never ends up anywhere. And so we're looking at how to get that code more publicly available and have the DACs help with that. And then to carry that through to the DAC and have more how to do user tasks in airborne data that would make it easy for users who are not in the team. And then for any data set, enters data cloud, provide automatically generated code snippets that would help with reading that data, and provide a means and expectation to release project developed code through the DAC to work with the team to get their code out. So what we'd like to do now is, from all the feedback we got, we developed over 150 use cases, and all of these use cases are what we're next having to go through and figure out what's available to be done and what's high priority among the community. And we'd like to use all of you folks attending today, both online and in person, to help us with the use cases. Those of you online, there is a document in the folder. And Michelle, what's the name of that document?
ESIP user story doc.
ESIP user stories doc. If you open that, you'll see all the different user stories. Online, we'd like you to identify from that list what you think are must-haves. And in this case, we're saying a must-have is, I have no other option. Without it, I can't, ... Then we have, for those of you here, we have cups in the front of the room, and you've received slips of paper. You get like 5, are you giving out 5, Sarah? Yeah, roughly 5 slips of paper to everyone. You look through your individual use cases and start to think about whether they are a must-have, a need, meaning I have a workaround, it takes longer, it's more effort, a want. If I had this, I could do something and my life would be so much easier, and not important at all. And so we've got these cups in the front of the room. I'm sending them out now, and you would decide among where your use cases fall, and then drop them into the cups. And we'll take about 5 minutes to do that activity. So those of you online, there is a Jamboard on the next slide here. That is a link. So if you open the slides that we're sharing here today, that link goes to the Jamboard. Also, if you look in the folder, there is a Jamboard if you open that. And on that Jamboard, put tickets of the must-haves that you identify from the long list.
I just put the Jamboard link on the chat, so you can just go through and read it. Yeah, so these are so now and we have
Must-haves.
what we really but these ones not
And just come on in and drop them in when you know what you think you'd do with that. If you have something you don't understand or it's not related to you, you can't really make a decision, we have more user stories. Come on up and get an exchange for a new one.
Can you go back to this slide?
I can. There you go.
I gave some people very few.
Yeah, get more. Folks online, anyone have any questions?
Is it something that
Do you see anything in chat?
Yeah, somebody asked for the long list, so I said that back. Sarah had already posted it.
Okay. And online, you're only identifying the must-haves. Beth.
Do you want us to create example user stories of those types of things that we are? I don't know very much.
Yeah, if you don't know, exchange with Sarah. She'll give you some new ones.
I can guess, but I can tell you what I think they're.
That's what we do sometimes, Beth. We guess.
Okay, let's get to know this. Okay, I'll take that too. I'm not an expert user either. I'm just not that's why I claim that I'm like so above the user, but yes. Right, so I just
Yep. Come on up. Stretch those legs. It's morning. We all need to wake up a bit more.
oh yeah. Okay.
Start. Grab another one. Okay. There you go. There's a pile. I just grab the same one. Put it. I have to select there. We'll get a different one.
So he was in a lot of my yeah. Just get some of them are probably
I actually texted photos.
Okay, wrap up your decisions and if you have your pile ready, just come on up and drop them in. If you're deciding still, step aside and then everybody can get through here. Fine. Hopefully something's for sure. And this frame of reference is we're the entitled chapter. You're ready. That's okay. So what we will do is just use these as an example because we have these. We'll just hand forward to each group. Right? Yes, let's do that. Yeah. And let's look at the online folks. Do they have what do they have? Jamboard. Oh, here I have it here. Okay, everyone, if you can wrap up your thoughts. We have a big pile of must-haves, and Sarah's been frantically typing some of them in, and we're very excited to see that there's so many must-haves. So. I'm going to not stop sharing for a moment. For those of you online, you'll see me stop sharing while I bring up the Jamboard too. Okay. All right. Did you have it already open? Oh, sorry. Can't see. There you go. Those are all the must-haves, right?
Yes.
Oh, excellent. And we've got a bunch on here. So this is where we divide the onlines into a couple of rooms to have discussion. So
Probably 2 rooms.
2 rooms, yeah. Yeah. So what we're going to do next is the online folks will go into breakout rooms, and you'll take your must-haves and start putting them into a cost and effect set of squares. So let me show you. If you're looking at the slides, it's the next slide where you can see that there's on the left-hand side, there's low cost to high cost. And on the top, there is low effect to high effect. And what you're going to do is take these must-haves and start placing them into these squares trying to determine, are they going to be a low effect or and a low effort, sorry, a low cost and a low effort, or a high cost, high effort, or anywhere in between there. So those of you here in the room, we have stickies, and which or even these we could.
Yeah, I think what we'll do is you guys work on sorting them together, and then we'll bring by some tape, and you can tape them in the appropriate place. We do have tape, yeah.
No, they didn't have regular tape at the desk, so we were going to do the sticky notes and just give a couple words. That might do it, right?
I don't think so.
No.
Yeah,
post it. Yeah. Oh, stick it with a post-it. Sure.
We'll figure out a way. Worst case, you take it on the
Break
floor
into 4 groups of 3 or so people on a board. There's 4 boards around the wall here, and we're going to give you out some must-haves, and now you separate those must-haves by effect and cost.
And I would suggest getting into a group with people you maybe don't know so well, so that you know, there's a variety of different perspectives, not just the people that you work with all the time.
Yeah. So head to one of the boards until the board looks full with a few people around it, and then we go to another board. Those of you online, go into a break room, sure, 2 break rooms, and take those must-haves, and if you look in your Jamboard, there's now group rooms that have the same table.
Groups together.
If I see, I'm sharing, right? So I can go to the next page here, right here.
Yes.
There we go. And so you can see that low cost, high cost, low effort, high effort table. Drop your must-haves in there using the sticky notes on the left-hand side of the Jamboard. Have a discussion about it. These are all must-haves, right? So that's fine. Yeah, just divvy it up randomly.
Yeah, I use a lot of today. Apologists, so learning along.
Now, how about
Yes.
Sticky notes for you. Those will work in holding them up.
Peter?
I don't know that I'm so there are
Online folks, I think you're going into one breakout room.
That was the USPS. So, and colleges. Airborne. Access. Yes, use a lot, but also yeah, like our time.
They're all out.
Yeah.
Brilliant. Right? Six an engineer.
And they,
It's just the not
Okay. Okay. Paper clips, rubber bands, hair ties.
I know.
It's okay. As long as I keep them together. And then we can go through these Wednesday next week. I was talking about auditing things. I'd like now to talk about those that are.
Okay.
Yeah.
As a project scientist, you might
I can set a timer. We're 5 up. We'll give them a couple more minutes. 10 o'clock. And we just need a couple to. So we got 6 minutes to go, so I'll give them some things getting put on the wall.
yeah.
Take your advice.
Yeah, take them for the.
So I put it
Go.
As an
Are out.
I'm nervous. So just categorizing metadata and it all. That's
Actually, we'll hand a microphone around so we can speak at the I have a microphone. Do we have a, yeah, we have a microphone. A microphone. We'll be using that in a moment.
Okay.
Okay.
That's Less like
So we're just sharing the screen. So when I go to the PowerPoint, we're good.
First.
Yeah.
So we just talked about this.
We'll talk about this on Monday. And then the next
Month.
month we can.
We'll bring Gal in.
Yeah.
The
Oh, we're there right
see
now.
this Jamboard updating.
No, I don't see this.
Yeah. Maybe they're still talking. Maybe they'll They can check the other pages.
Yeah,
Maybe
I
they fixed everyone.
I didn't see anything.
Maybe they don't understand.
So
Ask if the online folks are having any.
So you can
They're in room 2. All right, if you can kind of wrap up in the next minute your discussions online and in the room, if you can wrap up your discussions in the next minute or so. Each group got 4 to 5. Maybe 6.
yeah, these interactive activities go great.
It's good to get people out of each sense.
Yeah.
I mean, the effort production. But higher. I call it. Do it.
All right, everyone. What we're going to do now is take a moment to have everyone report on what's in your low effort, low cost category. So we'll start with online. If someone can share, excuse me, what's in that low cost, low effort category based on your discussions?
I can start. So there were a lot of things in the must-have bucket, and we honestly didn't have the time to go through everything. But we did put two stickies in the matrix. So we're able to put one in the low effort, low cost, and one in the high effort, low cost. And this is, I think both of these are from the data user's perspective, but some of them are more, some of the stickies in the must-have are more, general and not necessarily from the data user and or data provider. And and if anyone else want to chime in.
Okay. I think we're
Hi,
gonna
Colleen, this is Yashing. I just want to add a quick comment. I think the low cost and low effort, I think one aspect that we were thinking is, so the cost could be for either the user or the DAC or Estes, and same thing for effort. So the target that the effort or cost will apply to depends.
Agreed. Thank you for that additional thought there, Yaxing. All right, we're going to go around the room to the other groups here and have them just let us know what's in that low cost, low effort category.
Testing. Sure, I'll just read them off in our low cost, low effort. He said, as a data user, I need to search for multiple parameters that are in the same file. And also as a data user, I want to have access to a campaign catalog or flight catalog that provides the details of each flight for a time period of data. I'm kind of on the corner here, assuming it would probably be low cost, low effort, but not entirely sure. As a data producer, I want clarification on standards for cloud optimized data formats for Airborne. If those standards exist, sure, low cost, low effort. If they don't exist, not so much.
Yeah, good point. Thank you. Those are great items. That's something I hear an awful lot. And we're going to move over to the group over here.
All right, we have two in the low cost, low effort category. As a data user who is used to Earth data search, I want more airborne data in Earth data search because I don't know which DAC to look at for the data products I need. We put that in the low cost, low effort because we think it's just, get the metadata in there and make it available. And that seems like a reasonable thing to do. As a data user, I want to be able to access data grouped by campaign or geographic area or some other variable by accessing virtual collections. We think that if we get stuff into Earth Data Search, this one can be accommodated again at low cost.
Great items, and it does seem like if we can get that metadata in there at low cost. Yeah, right. Right, the costs on EBMG right now is adding that. Right.
All right, so we kind of had some in the middle, but our one low effort, low cost was as a data user, I want to be notified via a subscription service when a data product I previously downloaded has been updated. That seemed to us that could easily be done. And then we have some that are in the middle that we were not just, should I read those up as well? As an interdisciplinary data user, I want more mature and higher level airborne and field data products to choose from. And we wondered, when you're thinking about mature, maybe it's already at a level that the effort is then not as much after that. Weren't sure exactly what that meant. So, and then the last one was, as a user of airborne atmospheric composition data, I want a robust method to identify ground footprint of that data.
around footprints vary with every single instrument on the aircraft, which is part of the problem, is the variability and heterogeneity of all this data. And the last group.
All right, so we had two they were definitions and documentations. So as a data user, I want clear documentation and version notes for the data I have. That should be straightforward. And then as a data producer, I need to know the definition of the version of data. It's the same stack. So this should be two different. I don't care.
One more thing, right? The other day I ran into that where two different DACs had different ways of versioning. When is a new data product a new data product, right? When does it need a new version? That's not the same at every single DAC right now. So that's part of the problem. Oh, you're following me with the camera. I love it when you're not there. All right, so we're going to go over to Sarah now, who's going to wrap us up. We want to thank you for all of this. This has been absolutely excellent and turned out a lot better than we'd hoped even, I think.
Yeah. So yeah, thanks everybody. We are definitely going to look at your what you just did, what you decided were must-haves, what's low effort, low cost, easy wins for us, right? We'll actually talk about it at our airborne meeting next week. And we are currently working on a white paper that will have prioritized recommendations on the action items that came out of the workshop. We plan to present that to NASA headquarters and incorporate that into our future planning. We also have an AGU session and an AMS session where we will be presenting more, like what's another update of what has been happening with this. And we will also post updates on our webpage, which is at this link. I think the link is also in the session notes. So let me also, just what we got out of looking at all the feedback we got from the workshop is that users want one-stop services, user education, interactivity, and interoperability in a one-sentence summary. And also from their feedback that, yeah, that's it, right? Easy win, right? Also, the summary told us that we're doing better than we think we are, so that was good to hear. Yeah, so here's just some information about our upcoming conference sessions. You do have till August 3rd if you want to submit something. So we have two sessions at AGU, enhancing the interoperability and reusability of airborne and field data. And then the second session is open source science to facilitate use of airborne Earth observations. And then the AMS sessions, tending the treasure trove, advancing stewardship for non-satellite Earth observations. And we'd love to see you at any of those.
Great. Thanks, Sarah. And thanks everyone for joining us today, both online and here in person. We hope you found learning about the feedback we received really helpful. And thank you for your help in dividing up this work. Where you can see the task we've got at hand. This is a really big task to figure out what our recommendations to headquarters are going to be for what needs to be done first and foremost. So thanks all, and we really appreciate you being here today. Thank you.
So now we want to.
Thanks everyone online. We appreciate that you were here, and thank you to our speakers, Jocelyn and Gao. Appreciate it.
Thank you. Bye-bye.
Thanks, Jocelyn.
Bye-bye.
Bye. Bye, Gao.